everyone, welcome to my YouTube channel. I am Madam Rosmaya. In this video, we are going to discuss on the topic center of mass with the solved problems. And this topic is the topic for physics semester 1. Okay, center of mass. So the principles of center of mass is used to keep the object balanced, as example here in the given picture. Okay, like the rocks here. Okay, it is arranged like this and balance. They does not fall down. And another example here, the two children here play with the seesaw. Okay, they are balanced. And then the toy here, the bird toy here is balanced at the center of mass here. The point here, center of mass. Here, center of mass somewhere here. Here also somewhere in the along this vertical line here. And the diagram below shows a broom, how it is balanced at a center of mass here. If you hold a finger on the center of mass here, so the broom doesn't fall down. Okay, another example is in the football football game. So do you know how to kick a ball so that the ball takes a curved path into the goal? So you kick the ball in such a way that the force does not pass through its center of mass. So the ball will not only move forward but will rotate at the same time. And because of the rotation due to the Bernoulli's effect, the ball will follow a curved path, not a straight line. Okay, what is center of mass? Okay, so what is the definition for center of mass? So the center of mass of a rigid body is defined as the point where the whole mass of the body is assumed to be concentrated. So if the body has uniform density, center of mass will be located at the centroid. Example here, we have a cuboid. Okay, cuboid. So if we draw the diagonal here, so the intersection point here will be the center of mass of the cuboid. And another example is a sphere. Okay, sphere or a circle. Okay, a circle or spherical also, sphere also can. So you draw at least two lines. Diameter, this is a diameter, so the intersection point here will give you the center of mass. And this is a triangle, okay, for the equilateral triangle, for example. So you draw the line here, bisect these two, okay, equal distance, another line. So the intersection point here is a center of mass. So this is for the body with uniform density. Okay, if the center of mass for a physical body that is also uniform density, but it may be located outside the physical quantity. Okay, example here is in the case for hollow or open shaped object like this one. Okay, so hollow inside. Okay, so the center of mass still got center of mass, but it lies outside of the physical body. So the L shape here. Okay, example of the L shape here. So the center of mass lies outside. So you cannot balance this two example of rigid body here. Because you cannot put a finger to hold the hollow sphere here. Example, so you cannot. balance it, because the center of mass lies outside of the body, the rigid body. Okay, another case is of the distribution of separate bodies. So if involve more than one bodies, okay, in the system, consists of more than one bodies, so such as the planets of the solar system. So the center of mass may not correspond to the position of the any individual member of the system. Okay? For example, here Earth and Moon. Okay, so the center of mass lies somewhere here. So it does not may not correspond to the position of any individual member of the system, but you must involve both. Like this one, two bodies. So if you draw a orbit for the Earth, okay, another orbit for the Moon. Example here is Earth Moon system. So the Earth Moon system, okay, will form two orbit here. So the middle of the circle, what you call this center of these two circle, okay, will be the center of the mass. Okay, and the Earth Moon here will attract to each other with the gravitational force F. Okay, you've learned before, F equals to G M of the Moon, M of the mass, M of the Earth divided by R squared. So gravitational force, they always attract to each other. Okay, so if the distance between the two object is further away, and it form this one is orbit for this planet example, another orbit for another planet. So the center here will be the center of mass. So we assume that the two planets orbits in a circular in a circle, orbit in a circle. Okay, so next we discuss the formula. So what is the formula for center of mass? So the formula of center of mass consists of n particles. Example here, 3 particles of masses m1, m2, m3, ... and mn. At the points whose coordinates are x1, y1, x2, y2, x3, y2, y3, ... xn, yn respectively. Okay, so we imagine you draw a Cartesian plane. So you know the position of the 3 objects here. Okay, with mass m1, we name as the coordinate as x1, y1. So for object 2 with mass m2, coordinate here x2, y2, and the third object m3, mass m3 at the coordinate x3, y3. So the coordinates of the center of mass for this system is given by bar x, bar y. Bar y. So the formula is given by m1 x1 plus m2 x2 plus m3 x3 plus ... divided by total of their masses. Okay. In mathematical form, we can write like this. The summation mi xi, I from 1 to n, divided by summation of m from I1 to n, if we have n particles. For bar y, okay, we use m1 y1 plus m2 y2 plus m3 y3 plus ... divided by total of their masses. So in mathematical form, we write summation of mi yi, I from 1 to n, divided by summation of their masses, I from 1 to n. Okay, we try one example to get the center of mass in the form of coordinate bar x, bar y. Okay, so using this formula, we can determine, for example, just now the Earth Moon system. So it lies somewhere here. Okay, so the example, let's say the mass of this object 2 kilogram, this object 5 kilogram, and this object is 3 kilogram. The coordinates is given for one object, first object, object 1, 2, 3. Coordinate of object 5 kilogram, 4, negative 1. Okay, 1, 2, 3, 4, so negative 1. And the third object 3 kilogram at the coordinate 5, 6. Here 5 and here 1, 2, 3, 4, 5, 6. Okay, so the bar X will be, so you substitute the mass, first object, coordinate of x1 is 2. Next is the second object, coordinate for x2 is 4. And lastly, 3 kilogram mass, coordinate is 5. Okay, then the total of mass, 2 plus 5 plus 3. So the answer is 3.9. Coordinate for bar X is 3.9. So we do the same for bar Y. Okay, bar Y, the formula here, MIYI. So for the first object, mass is 2 kilogram. The Y1 will be 3. Okay, second object, mass is 5 kilogram. Y coordinate is negative 1. And the third object, 3 kilogram mass. And the Y, coordinate Y is 6. Okay, then total of the mass, 2 plus 5 plus 3. Okay, total of mass. So the answer is 1.9. So this is the bar Y. So refer to the Cartesian plane here. The point is somewhere here. Okay, 1, 2, 3.9. So bar Y is 1.9. Okay, so the center of mass lies somewhere here. Okay, that is the first example. What is the difference between center of mass and center of gravity? Are they the same? Are they the same? So center of mass just now, definition is given by point where the whole mass of the body is assumed to be concentrated. So for center of gravity, it means that the point where the whole weight of the body is assumed to act. Okay, here involve weight, but center of mass involve mass. So that's mean because of the word here, weight. So the position of the center of gravity depends on the values of the acceleration due to gravity g, because the weight is equals to mg. So mass times the acceleration due to gravity g. So therefore, the position of the center of gravity and center of mass need not be at the same point. So the center of gravity and the center of mass are at the same point for particles in a uniform gravitational field where g is constant. Then only they share the same position. Or if the size of the object is small, so that the gravitational field is uniform throughout the object. Okay, the formula is given by bar X is we instead of using mass, so we use weight, mg. So mgi xi divided by mgi. For the bar Y, okay, summation of mgi yi divided by summation of mgi. Okay, let's try the example on this one. So the g1, g2, gi are the acceleration due to gravity g at the position of the particles of mass m1, m2, mi respectively. Okay, so we try this question. The masses of the Earth and the Moon are 6.0 times 10 to the power of 24 kilogram and 7.4 times 10 to the power of 22 kilogram respectively. So the distance between the Moon and the Earth is 3.8 times 10 to the power of 8 meter, and determine the position of the center of mass of the Earth-Moon system. So the solution, this is the Earth and this is the Moon. Okay, so the mass is given of the Moon, of the Earth. Then the distance, this is the center of mass individually for the Earth and the Moon. So we join this line. Okay, so the distance between them is given 3.8 times 10 to the power of 8 meter. And we are going to determine the center of mass bar X. Okay, it lies somewhere in between the moon and Earth. Okay, so imagine the Cartesian plane here. So we use the Earth as the origin. Okay, you can also choose moon here as the origin. It's up to you. Or other position, as long as you know the distance. So better put here because we know the distance between the two Earth and Moon, between them is given 3.8 times 10 to the power of 8 meter. The only given distance is this one. So that's why we choose the origin is here. Okay, for the Cartesian plane, yeah. Okay, so here is the origin, 0, 0. So this point will be distance 3.8 times 10 to the power of 8 and 0. Okay, y coordinate, x and y coordinate. So y coordinate is 0, so no need to calculate for the bar y. We only calculate bar x because coordinate of y for both Earth and Moon is already 0. Okay, for bar x, okay, we find the mass times x for Earth. First is the Earth. So mass of the Earth is 6 times 10 to the power of 24 kilogram, and it's at the origin, so times 0. Okay, at the origin times 0. Then for the Moon, mass is 7.4 times 10 to the power of 22 kilogram. And the distance from the origin here, 3.8 times 10 to the power of 8. Okay, next is the total of mass. Okay, total of mass, Earth and Moon. So we get the answer 4.6 times 10 to the power of 6 meter. Okay, so where is this position? Refer to the diagram just now. It's somewhere here. We know that the diameter, the radius of the Moon is about 6 times 10 to the power of 6 meter. So 4.6 mean less than 6. So it lies somewhere here. Okay, this is where the bar X or center of mass is. So from the top view just now, this is Earth Moon system. So it lies somewhere here. The plus cross here means the center of mass. This is top view. Okay, so this is side view somewhere here. Okay, so that's all for this video lesson. Okay, so don't forget to subscribe, comment and like if you want to see more videos from me. Okay, thanks for watching.